triangles, and angle bisectors. Find the value of each variable. Simplify your answers as much as possible. If necessary, you may learn what markings on figures indicate. So in this case, if you click on this one, it'll go through all the different markings. The only one we need to worry about for this one is the angle arc. So if you have an angle arc, what that means is those two angles are congruent to each other. So one arc to one arc means those are congruent. Two arc to two arc means that those two angles are congruent. So you match the number of arcs to see the congruent angles. So those are the two that we have to worry about for this one. So if we have two angle bisectors, which is what this is, when you have a line going through an angle and it's cutting the angle in half, meaning that both sides are the same, then it's called an angle bisector. So we have an angle bisector theorem. In a triangle, an angle bisector separates the side opposite the angle bisector into two segments whose lengths are proportional to the lengths of the other two sides. So that sounds a little bit funky. Let's scroll down here so you can actually see some color in the diagram here. So we have this first diagram, which it matches this one up here a little bit. Close, not quite, but it's pretty close to the scenario. So what this is showing you is that you have two pieces of the triangle. So we have an angle bisector, arc to arc. So this cuts the angle in half. So what it does is it makes the side AC proportional to this opposite side. That's what they mean, the side opposite the angle that's cut. So opposite the bisected angle. And then and it's also congruent to the other length of the two sides. So we wouldn't want the shared one. We don't want the angle bisector. We want the other side here. So we have opposite, and then it's congruent to the other side. Not congruent, sorry, proportional. And then we also have opposite and proportional side. So when we put it into a proportion, we want BD is proportional to CD. So these are both their opposites. So we have opposite. And then AB over AC. So these are both other. That's how we'll, I guess, refer to them. So we have opposite and other. And then we also have, and in this case, I'm going to say bottom triangle and top triangle. So we have top and bottom. So this is kind of how I like to do proportion. It's like a little map. So we have top, opposite. So if I go to the top, this is one they marked in red. So top opposite is BD. And then bottom opposite. So I go bottom, opposite, DC. So this just gives us a map. So when we fill this one in down here, that's basically how they did it. So top opposite, if I go to the top triangle and the opposite, and they did it actually a little differently than I did, but they did bottom on and then top. So they flipped them, which is not a problem. It wouldn't actually matter. So I could actually write this proportion the same way I wanted to, where I go top opposite, well, that's x minus 2, over bottom opposite, well, that's 2, equals, and then I'm going to go top other. I'm going to go back to the top triangle, and the other length here is 6, and then bottom other, that length is 4. So they actually, because the given information is showing that the whole thing is x, so they filled in this x minus 2, I believe, because they didn't explain that fully I didn't explain it fully when I started jumping in. They give us x and 2, so this length must be x minus 2 that we already know. So that's where they got x minus 2. So it doesn't necessarily matter that I flipped the proportion as long as it's flipped on both. Because when we cross multiply, I'm still going to multiply the same two things I would here. And when I cross multiply this way, I'm still going to multiply the same two things. So it's okay to flip it as long as you flip it the same. And then just like I said, once we get there, we're going to cross multiply and solve for that variable. And we have to do that twice because we have two different triangles. So let's go ahead and clear and click start here so we can get going on this one. Okay, so we have an angle bisector that's shown with the arcs here. So remember, we're going to have opposite and other, and then I'm going to go top and bottom. It's just how I'm labeling my two triangles. So the top triangle, the one that looks like it's on the top, the bottom triangle looks like it's on the bottom. So we have our amounts here. So let's go ahead and fill this in. We're just working on the first triangle. We'll go to this one in a moment. So we have top opposite. So I'm going to go to the top triangle, and the opposite is 6. And then bottom opposite. Bottom opposite, 4. Other for the top. So remember, we're not looking at the angle bisector. We're looking at the other side. So that one's x. And then bottom other. So bottom other, I have 6. Now I can cross multiply here. And I get 6 times 6 equals 4 times x. 6 times 6 gets me 36. 4 times x is 4x. And then to get x by itself, remember I have two sides of an equation. I'm going to divide by 4 on both sides, because any number divided by itself cancels, and I get to drop x down all by itself. So I have 36 divided by 4, which is 9. So I know x equals 9. I can go over here and fill this in. X equals 9. So now I get to deal with this other proportion here. I'm going to do the exact same thing. I'm going to write the same map. Other. But instead of top and bottom, this time I'm going to go left and right so that I can describe the triangles a little bit more clearly. All right, so let's go ahead and start filling this proportion in. So I have left opposite. So on my left triangle, I'm going to go left opposite this. Well, I don't have anything here, right? But I have the whole thing, and I have this piece. So I'm going to say 6 minus y. The whole thing is 6, and I want to subtract this piece, which is y. So 6 minus y. And then I have right opposite. So I'm going to go right triangle, and I'm going to go opposite, and that is y. Now I'm going to go to the other side of the proportion here, other left. So I have to go back to my left triangle, and I want the other length, which is 8. And then I'm going to go other right. So on my right triangle, and I don't mean triangles and it has a 90-degree angle, I mean the triangle on the right, that the other length on this one is 4. So remember, other just means we're not using that angle bisector. So we're kind of ignoring it. It's creating this proportion or this relationship, but we're not using it in our equation. So we're going to cross multiply, and we get 6y, or 6 minus y, and that's a quantity, and that's times 4 equals 8 times y, which is just 8y. So now what I need to do is take this 4, and this is one of the bigger mistakes that students make. They'll just multiply the 4 by one thing. It has to multiply by both. You're distributing it. You're saying 4 times 6 and 4 times negative y. So we get 24 minus 4y, because I have to distribute it to both, equals 8y. Let's move this over here so it's out of the way. So now I want to bring these y's together. So I'm going to add 4 to both sides. Remember, there's two sides of the equal sign. And 24 gets brought down. Negative 4y plus 4y, they cancel. Any number plus itself, or any number that's positive and negative, and you're adding, you subtract, and we get 0 in this case, which is what we wanted. So 8y plus 4y, we get 12y. And the last step here is to divide by 12 on both sides. So we get 2 equals 12 divided by 12 cancels, y. All right, so y equals 2, and we're going to check. Okay, next, clear. All right, so we get to do this a couple more times here. Okay, so now we're going to set up a proportion. Again, it's the same proportion each time. So we have opposite, other, and then we just need to look at it real quick. Do we have top and bottom, or right and left? In this case, we have top and we have bottom. So top, opposite. So the top triangle and the opposite. Well, there's nothing there. This is the one where we have to take the whole thing and subtract what we're given. So we have x minus 2. Bottom opposite. That's 2. And then top other. So I'm going to go back to my top, and my other length here is 6. And then bottom other. So I'm on the bottom triangle, and my other length is 3. All right, so let's cross and multiply here, and we get, remember, it's not 3 times just one of these. It's x minus 2 times 3. So I'm going to distribute on this one. And then 6 times 2, we get 12. All right, so now I'm going to distribute, and I get 3 times x minus 3 times 2, which is 6. All right, so now we only have one x in this case, so I want to bring my constants, my regular numbers, together. So I'm going to add 6 on both sides, and I get 3x. Negative 6 plus 6 cancels, and this equals 18. My last step is to divide by 3 on both sides. X equals 6. All right, so we have our first answer here, 6. And we need to do our other proportion here. I'm going to go ahead and clear all this out just so I have room. So I have opposite, other, and in this case I don't have top and bottom, but I do have right and left. So just pick something that describes the two triangles so that you know which one you're talking about. So now I want to go right opposite. That's 6. Left opposite. That's 8. Right other. So I'm going to go back to my right triangle and I'm going to go, right side. I was doing these backwards. Darn it. I'm going to switch these two because I went left and right because that's the way that I'm reading it. Silly me. Left, then right. That's usually how I do it just because that's how I read it. All right, so left opposite, that was 6. Right opposite, that's 8. That was silly. Left other, so that's the 9. And right other, that's the y. Okay. So let's cross multiply. We get 6 times y, which is 6y. 8 times 9, that's 72. And then I want to get y by itself, so I'm going to divide by 6 on both sides. So we get y equals, let's see, we get 1, 2, so we get 12. Check. All right, one more. Okay, so I'm going to start writing my proportion again, opposite, other. And then this first one has a left and a right, and I'm going to write it that way just because, again, I always read it from left to right, so it's easier in my head to keep it that way. So I don't get things mixed up. So I'm going to go left opposite. Opposite my angle is 3. Right opposite, it's 2. Left other, so my other side on my left one is x, and my right other is 4. All right, so now let's go ahead and cross multiply. So we get 4 times 3 is 12 equals 2 times x, which is 2x. So now I'm going to divide by 2 on both sides of my equal sign, and I get 6 equals x. All right, so I'm hoping this definitely starts to make a little more sense now. You just set up this little map, and that will help you fill out your proportion each time. So I'm going to clear this out so I can rewrite my next proportion. So opposite, other, and then this one I have top and I have bottom. And again, I put top to bottom because that's kind of how I read it that way, so it just makes it easier for me to make sure that I'm doing the right one. So top, opposite, there's nothing there, so that means I have to take my whole thing and subtract what I'm given. It's going to be 9 minus y. And then bottom opposite, I have y. All right, top other, I have 8, and bottom other, I have 4. All right, let's cross multiply. So remember, it's the whole thing times 4, not just 9, not just y. Both of them will be multiplied. And then we have 8 times y, which is 8y. All right, let's distribute this 4. So we get 9 times 4 is 36 minus 4 times y, which is 4y equals 8y. Now I want to bring my y's together, so I'm going to add 4y on both sides of my equal sign. 36 gets brought down. Negative, positive, 4y, 4y, they're the same thing. One's positive, one's negative. They cancel to 0. Equals 8y plus 4y, which is 12y. And we divide both sides by 12 so that we can get y by itself. So in this case, we end up with 3, because 36 divided by 12 is 3, equals 12 divided by 12 is 1, so y drops down. All right, so we're going to check this last one. We're going to be done. All right, clear. We finished another one. Yay.